Alexa, tell the stepper to go to 9600 pulses.
You got it. See you at 9,600 pulses.
Alexa, tell the stepper to go to 3 turns.
Cool. I sent the stepper to 38,400 pulses.
Alexa, tell the stepper to go home.
You got it. See you at 0 pulses.
About 2 years ago, I did my first video on connecting the WAGO PFC with AWS and Alexa Voice Service, or the Alexa Skills Kit. Since then, pretty much everything has changed. Lambda, IoT, the Skills Kit itself, and WAGO's Cloud Connectivity Suite for eCockpit. So this is going to serve as a brand new tutorial, starting with creating an IoT thing, walking all the way through the voice skill and the eCockpit project. So for this, I'm using a PFC 100, 75673 stepper module, and an Echo Dot. So let's get started. So in AWS, we have the Alexa Voice Service, which sends data to a Lambda function. That Lambda function sends data into the IoT thing shadow, then to the PLC. The PLC can respond with data which goes all the way back to the Alexa voice skill. And all of this is wrapped in an IAM wrapper. So the very first thing we'll do is we're going to go to aws.amazon.com. And if you navigate to the AWS Management Console, you'll get a whole console of all the services available. You can search these, of course, in the tab here. And you can also navigate through them in their categories. But we're going to start by going to the IoT core, because the first thing we'll do is we're going to create an IoT thing. This is going to act as the hub to send data in and out from the PLC into the AWS service in general. So we'll go to AWS IoT, we'll go to Manage, and I don't have any things in here yet, so we're going to register a thing. We'll create a single thing, and we're just going to name this. And we're going to leave all these other fields blank. We don't need to use any of those. We're going to do the one-click certification creation. And it's going to give us three different files here. It's going to be our certificate, our public key, and our private key. Now we're not going to use the public key, so we're not even going to download that. We're only going to download the certificate and the private key. And once we click download on both of those, you can see they're in my downloads bar. We're going to activate those. Next, we'll go to attach a policy, and we don't have a policy created yet, so we can't attach it. So we'll come back to that after we register this thing. So there we go. There's our thing right there. Next, we're going to go down to Secure, and we're going to go to Policies, and we're going to create a policy. We're going to name this. And I prefer to actually do this a little bit different. Rather than using the wizard, I like to go to advanced mode, and I like to build a JSON myself. So I've got a pre-constructed policy here, and essentially I'm opening up my IoT service so that anything with certificates or credentials to get into the IoT service can perform any action. So you can always limit this, of course, but I found this is it's very reliable in getting it to work. So I'm just going to copy this text here and paste it into my JSON field and click Create. So there we go. You can click on this and you can see that the JSON text that we put in here is there. And so now we can go to back to our certificates under Secure, and I'm going to click on this, and under Policies, I'm going to go to Actions and attach the policy. So we're going to select our PFC IoT policy and attach it. Now, in our IoT thing, if we go back here to Manage and we go look up our thing, if I click on Interact, you'll see now I've got my endpoint. I'm going to need this for connecting my PFC. And also I've got my topics here for MQTT, so I know how to interact with my thing shadow. So we'll come back to this after we've created some services around it, but essentially we've got our thing created, and we can direct our PLC to it by this endpoint. With the IoT thing created, next we need to go to Lambda, and we need to create a cloud function to be able to get data from the voice skill into the IoT things service. So I do have a Lambda function in here, but we're going to create a new function specifically for this. So I'm going to call this my Alexa stepper function. We're going to be using Node.js version 8.10. We'll choose an existing role, which is Lambda basic execution. This is a default Lambda role, and we're going to leave this at author from scratch. We'll create the function, and now we need to basically set a trigger for this. So what's going to trigger this skill is going to be the Alexa skills kit. We're going to later create our custom skill, which will then be pointed at this. So we're going to go here to click where it says configuration required, and if we scroll down, it says configure triggers. We basically, I'm going to disable skill ID. I don't need to cross-check the ID with the voice skill, especially since this is just a prototype. So we're going to disable that, click add, and it says unsaved changes, so we're going to save that. And now, if I click on the Lambda function up here at the top, I'll leave all these things on the right, the outputs basically of the function. If I click on the top, it gives me my code editor. Now, I'm not going to go into detail about the specific code here. I actually did that in my last video, so you can go back and rewatch if you'd like to understand the structure of the video. But I'm going to basically create some very simple skills here that I have pre-written. So the first one I'm going to copy in here is called Alexa skill.js, and if I right-click here, I'll do new file, and I'm going to call this Alexa skill.js. I'll double-click to activate that window, and I'm just going to paste my code in there. I'll click save. And then we're going to go to index.js, and we're going to do the same thing with my index file. So these files are all posted on GitHub, and you're welcome to reuse them and also ask questions about them. So I've got the code in here, and essentially what the code is doing is the code is saying when it receives the intent from the skill, so in this case it's the move absolute intent, it's going to parse the intent, which is the incoming object. It's got the identification as well as the values that we're passing from the voice skill. It's going to parse those and make some decisions based on what's going on. So please take some time and go through this code and see what's going on here, but it is very simple and hopefully very straightforward and easy to follow. So once I've saved both of those, I'm essentially done here. The thing to keep in mind is up at the top you've got this ARN, and this ARN is going to be useful, so I suggest you can bounce, of course, back and forth between Lambda and the skill service, but you're going to need this value right here, this ARN, so either jot it down or be ready to come back to this, but essentially we're done with the Lambda function of this. Third step here, we're going to actually create our custom voice skill. So we're going to do this by going to developer.amazon.com. We're going to go to the developer console, and we're going to go to the Alexa skills kit. So before we do this, it's important, I think, to understand the way that the voice commands are structured. So let's take a look at those. So if we use the phrase Alexa tell the stepper go to 15 turns, Alexa is a wake word, stepper is how we invoke this function. Both 15 and turns are slots, 15 being the number that we're going to pass and turns being the metric of resolution. Sure. Let's go ahead and create a skill. The skill name, we're going to call this my Alexa stepper skill. I'm going to leave this custom.
I'm not sure.
And we're going to start from scratch. So as you remember from the slides before, we need an invocation name. In this case, we're going to use stepper, just like in the example. We're going to save this. Okay, and now we need to go to the intents. But actually, before we go to the intents, I want to talk about custom slots and the different slots that are available. So I'm going to click on slot types now. We have all these built-in things, and you'll see those when we go to build the actual intent. But I'm actually going to create my own slot to start. I don't need. I'm not going to use a standard number or anything. I need to actually get a metric back. So what I'm going to do is I'm going to create a custom slot type, and I'm going to call this list of metrics, or list of metric. We're going to create this custom slot type. So the value, we're going to say pulses. Just like in our statement, we're going to say, go 10 turns or 10 pulses. We need to be able to differentiate between those. So we're going to have pulses and we're going to have rotations. And in those, we need to add some synonyms. So under rotations, we could also call it turns. We could call it revs. We could call it revolutions. That's probably good enough. Under pulses, we'll say ticks, counts. Yeah, that's good enough as well. And we'll save that. So now we've got a custom slot type that we'll be using. So now we can go back to the intent and we can add an intent. And we're going to say, we're going to call this intent move absolute intent. If you look at our Lambda function, we've got a move absolute intent call in there. So it's going to be very handy. So let's back up. So it's going to be the statement's going to be tell the stepper go to x counts or x turns. So we need to call that out. So it's going to infer that you're going to use the wake word and that you're going to call out the invocation. So we just need to complete the rest of the sentence. So go to, we're going to call this position. So this is an object in here. Go to position and metric. Okay, so for example, go to 10 turns. We're going to add this. We're also going to say go home because we want to be able to go to 0 very simply and go to home. We like all of those. So position. So position is what? It's going to be a number. So we need to assign it the slot type, Amazon.number. So this is going to take the spoken number. So when I say 3, it's going to come through as text, but we want to turn that into an actual number. So even though it's being received by the voice skill as 3 spelled out, we want it to pass a number. So we'll do that there. And then the metric is going to be our list of metrics, so it's going to be able to infer our definition there. So we're going to save this model now. So now we've got our invocation created. We've got our intent created. We've got a custom slot type. So there's really only one thing left to do, and that is point this thing at an endpoint. So we talked about this before. I want to send it to an AWS Lambda ARN number. It's expecting that number here. So what we need to do is go back to Lambda and go to the function that we created, and we need to copy this value. And only this value. And we need to stick that right there in that default region slot. So we've done that. We're going to save the endpoint. And there's some really cool stuff that we can do in here now that we've done that. If we go back to our intent and we build the model, it's compiling all this and it's building, doing some error checking, making sure that everything looks good and that we've completed all the steps. Okay, and now the build is completed. We can go now to test. And I'll enable testing on this skill, so I can type in, a phrase that we would use. So tell stepper go to 3 turns. It's going to pass the field. So here's all the data that it passed to our Lambda function. And here is the return from our Lambda function. So if it was erroring, you would see it would return some kind of error. It would also log that to CloudWatch, so there's another avenue of debugging. So there we are. We've completed our custom skill, and now we can move to the PLC side of things. Okay, so the last steps here, we need to get the PLC connected and we need to load the PLC program. So again, I'm not going to go into the code, but I am going to step through the settings in the web-based management and then do a little bit of an example with the eCockpit runtime. So first I'm going to go to the web-based management on the PLC. So this is accessed by putting the IP address in a web browser. Couple of housekeeping tips. Number one, your network settings need to be set properly, of course. So if we go to TCP/IP, you'll see I've got a static IP set, as well as some DNS settings plugged in here. These are Google's DNS server settings. Very reliable. I also need to, under the routing tab, I need to enable a gateway and point this towards my local gateway, so point it at your router. And lastly, you need to have the clock set properly. So this is required to verify the credentials when you're logging into TLS encrypted services. So all those things being set, when you're able to ping Google and the clock is set properly, then you can move on to cloud connectivity. And here's where we're going to set up our AWS service in the PLC. So first, enable the service, change this from WAGO Cloud to Amazon Web Service. And now we'll need the host name. So we'll go back here to our IoT thing. We'll go to our Interact tab, and we're going to copy the endpoint for our IoT thing. Going to come here, we're going to paste this in. We're also going to add the client ID. Which is our thing name. Now we need to load the certificates here. So there are several ways to do this. The way I prefer is just using an FTP server or using an FTP client. So if I do this, I'm going to go to the IP address. And I'm actually going to log in as root. I do this because it lets me add these files to our otherwise protected directories. Of course, change your root credentials after you log in the first time. So you'll see the file path we're going to is the etc/ssl/certs directory, and we're just going to go to our downloads folder where we've got our certs that we just that we downloaded. Okay, there we go. So we've uploaded the certs, they're there. Now we just need, just copy one of these because I need the full file path, and this is the easiest way. So now that I've copied that, I can go here and I can go to etc /ssl certs / my file name. So there's my my certificate-certificate.pem.cert, and then I can do the same thing. In fact, I can just copy this whole thing, dump it into the key, because this is going to be private.pem.key. Okay. Now I'm going to change this data protocol from WAGO protocol to native MQTT, leave everything else here, and click submit. Now you'll notice once I've clicked submit, it's still going to say changes will take effect after next reboot. So now we need to go and reboot the controller. So let's reboot it, and I'll see you back here. Once we've rebooted, we can then navigate back to cloud connectivity. Now you'll see it shows operation running, and it is connected. So this is great. If we had a setting wrong, it may say disconnected here. Always check your security settings in AWS. Make sure that you've got the policy right, and make sure that all the fields here are properly called out. So I've seen definitely a lot of problems with misspellings or just typos in these fields. So have a look at that. Okay, so that's all done. Next we're going to move on to eCockpit, and we're going to talk about the eCockpit project. So I've also included this project in the GitHub repository. There are a few things going on here. So I'm actually using the MQTT, the WAGO App Cloud library version 1.2.4.13. I'm using this because it supports native MQTT. So if you're familiar with the past versions of this, it only supported WAGO protocol, but since then WAGO's made available just a generic publish and a generic subscribe block, as well as a status, so you can get the status of your connected device. So with all that, you can build your own JSON strings to send, and you can also receive raw JSON, which is also nice. So like I mentioned before, I'm not going to go through this code in detail. We can just look at what's going on here. I'm using a subscribe block basically to monitor my AWS Thing Shadow update accepted topic. So this is going to be this topic is going to be published to anytime the Thing Shadow has accepted an update. So the voice skill is going to send data to Lambda. Lambda is going to update the IoT thing. When it updates the IoT thing, it's going to be published onto this topic. So we can monitor that and see what happens. So we're going to connect to the device, and we're going to run this project so we can see what the raw string looks like when we receive it. What I'm doing here is I'm actually copying some data into a raw string. So if we navigate down to the bottom here, I've got my subscribe receive string here. We won't be able to see the whole thing because it's rather large, but you can at least see the data that's coming in here. So when we say, Alexa, tell the stepper go to 5 turns.
Sure thing. Sending stepper to 64,000 pulses.
So we've got the data being populated in here, and we're able to just parse this using some sometimes lengthy functions that we've created. But I'm just picking this apart and creating essentially a Thing Shadow object. So we can monitor this. You can see this the first time and then build your program based around this. But as you can see, it works very simply. So there you have it, all the steps necessary to create your own custom Alexa voice skill and tie it all the way back to your PLC. So please leave any questions you have in the comments section below. Like the video and please subscribe to the channel. Thanks for watching.